Okay, so we are solving the problem 1 minus 2xy dx plus 4y cubed minus x squared dy equals to 0. So this is an ordinary differential equation. So, and it is an exact equation. Why am I saying it's exact equation? Exact equation is in the form m of xy dx plus n of xy dx equals 0. So comparing the form to the question, I can boldly say it is an exact equation. We can also go on by further testing whether this equation is an exact equation, because there will be a situation where the question or the differential equation will look similar like this, or will be in a form this, but would not be an exact. So further testing for exact is that I'll choose mine m. So by comparing the original equation to the form, my m equals 1 minus 2xy. So my m equals 1 minus 2xy. Whilst my n equals 4y cubed minus x squared. So the idea behind an exact equation is that after determining whether the equation is an exact, we first write the values of m and n as shown below, m and n. And also after that, we differentiate m with respect to y. So differentiating m with respect to y, this is our the whole m. So we are differentiating it with respect to y, with respect to y, with respect to y. Henceforth, the m with respect to 1 is 0, because when you differentiate a constant, you are getting 0. And the derivative of m with respect to y is 1, because when you differentiate y, we are getting 1. So we keep the minus 2x constant. So minus 2x times 1, we are still getting minus 2x. Also, getting the n part 2, we are differentiating n with respect to the x. So this implies we are dealing with the x. So please don't be confused. So only the x part. So from this equation, my n is this. So differentiating the n with respect to only the x, we are getting the whole of this to be 0, because we are differentiating only this with respect to x. So we are getting minus 2x. So we can see clearly and obviously that my minus 2x, when I differentiated my n, is equal to minus 2x. So when it happens like this, then my equation or differential equation is said to be an exact equation. Okay, so further, the idea behind that, after getting or proving this, we now do our rare situation, or we now deal with our rare situation. So we integrate m with respect to x. Remember, this part was just testing, when we were testing for an exact, and this part. So this and this, that's the derivative part. It's when we are testing, but this is the original solution. So we integrate m with respect to x. But remember, when we were testing, we differentiated m with respect to y, so it's like vice versa. So differentiation and integration are inversely proportional. So when I differentiate the solution of an integration will definitely be the derivative or the derivative, whilst the solution for the derivative two will be the answer for integration. So that is just by the way. So when we integrate m with respect to x, so this is my m function. So I am integrating m with respect to x from my equation. So because we are integrating m with respect to x, here when we integrate x, we are when we integrate 1, we are getting x. When we integrate 2x, we are going to get x squared over 2, but the minus the 2 here will cancel the over 2. So you see, when we differentiate, we are going to get x squared on 2. So that 2 will cancel the 2. So that's why we had x squared. Then we keep the y the constant because we're integrating m with respect to x, not y. So we attach y to it. Then the next thing to we integrate n with respect to y. So my n function, where is my n function? This is my n function. So my n function, when integrate n with respect to y, note that we are only concerned with the y. So my x component will be 0. So when we integrating my 4y cube, we are getting where is y exponent 4, because when we integrate, we are going to get 4y exponent 4 all over 4. So the 4 will take away the 4, leaving my y exponent 4. Okay, so our general solution is given as this. So we take the terms of the integral of m, which is x minus x squared y. Then we take the term of the integral of n, which is y is 4. Then we add them together. Then we equate it to a constant. Thank you very much.